Hey everybody, so like I said, heading back into the lab, and the theme of this whole chapter has been finding out relationships about the periodic table. And one of the bigger ideas I keep revisiting is that if elements live in a column together on the table, which is a group, they are supposed to have similarities both physically and chemically. That doesn't mean they're identical. It just means that they are similar. For instance, the one we've been working on with the whole dot structure in the reading the table was, group 1, for instance, all end in S1. Now, it's not the same S1, though, right? If I work my way down the column, hydrogen's 1s1, lithium's 2s1, sodium's 3s1, potassium's 4s1, 5s1 is rubidium, 6s1 is cesium, and so on. Right? So what's similar is they all end in S1, but not identical, right? 1 energy level, 2 levels, 3 levels, 4, 5, 6, which means the atoms are getting bigger. So we expect them to act similarly because they all have 1 valence electron, but they might not act identically, right, because of the size effect. We're going to test that theory. Right? Today, what we're going to do is we're going to look at the reactivity in a different group. The group we're looking at is going to be group 2, right, from the periodic table. So we're looking at the reactivity of group 2 metals that are in the nitrate form. And putting them with a nitrate simply lets me dissolve them in water. So we really don't even care much that they're with nitrate. All we care about is the identity of the group 2 metal. So if you look at my little chart here, what I've done is I've set it up so that we're working our way from beryllium to magnesium to calcium to strontium to barium, working our way down group 2. We're going to conduct 3 separate experiments, right, in this one miniaturized setup. Right? The first experiment is we're going to react the group 2 element with a carbonate. And all the carbonates are paired with potassium. So again, just like the nitrate part didn't matter, neither does the potassium part of this. But I want you to just know what we're working with. All right, so we're working with the group 2 metal with potassium carbonate for experiment 1. For experiment number 2, we're taking the group 2 element with a different substance. This time we're taking it with potassium sulfate. And then experiment number 3, we're going to take our group 2 metal with potassium chrome. All right, how do we set that up in this one miniaturized setup? Well, what happens is I keep my group 2 metals right here down the left column. Then I've got the things they're reacting with up top. So what we're going to do is we're going to cross matrix them to mix them. So what we'll do is we'll take 10 drops of each of these things. And with the 10 drops, we would first put 10 drops of beryllium in that first well. 10 drops of magnesium, calcium, strontium, barium. We do that all the way across. Beryllium, more beryllium, magnesium, more magnesium, calcium, calcium, strontium, strontium, barium, barium. Then what we do is we go and get the substance we're working with, the carbonate, and then I put the carbonate in, 10 drops, but going down the column. So now each one of these group 2 elements is working with a carbonate. And then we would give them time to react. Then I would go and I'd do it with the sulfate. I'd go take the sulfate, 10 drops, 10 drops, 10 drops, 10 drops, 10 drops. I'd give them time to react to see what happens. And then lastly, I'd go with the chromate, 10 drops, 10 drops, 10 drops, 10 drops, 10 drops. All right, we give those about 5 to 10 minutes. We shake it gently, and then we let them react. And what we're looking for as a sign of our reactivity is the formation of a solid, all right, which is called a precipitate. And so a couple of things that I wanted to talk through that's going to help you with some lab stuff. In each experiment, we've got variables, right? And there's 3 types of variables. Right? There's the manipulated, there is the responding, and there's the control. So 3 variables. And we've talked about this before, but this is just a little refresher. Like the manipulated variable is the thing that you change on purpose. The responding variable is what you're watching for. What is it that we're looking to detect? And the controlled variable are the things we keep the same on purpose. All right, so if we look at our first experiment, right? I'm going to even cover up the other 2. I only want you to see one experiment at a time. If we're looking at experiment 1, in that experiment, we have all 3 of these variables. Like the manipulated variable is the thing that we change on purpose. So if you think through the experiment, we're putting beryllium with carbonate, magnesium with carbonate, calcium with carbonate, strontium with carbonate, barium with carbonate. Right? So the carbonate can't be the manipulated. I'm not changing it. It's carbonate every time. What must be the thing I'm changing on purpose are the group 2 metals. Right? So group 2 metal is what I'm changing on purpose in experiment number 1. The responding variable in experiment 1 is what I'm watching for. And like I said, when we mix these, we give them time to react. We're looking for solid. Right? So the responding variable is the amount of solid, which is going to be what tells you how reactive they are. Right? The last is the controlled. Right? And there's lots of different controls. One easy one we spotted was the carbonate. Potassium carbonate. But there were others, right? I used 10 drops in each one of these. So the drops is a control. I reacted them all in the same well plate. So the well plate is a control. It's all in the same lab at the same temperature. Temp is a control. The room pressure is a control. All right, so these are all different things that we have being the same on purpose. So none of these should be affecting what the outcome of our experiment is. We just want to see what does changing the group 2 metal do to the amount of solid when I reacted with something. As part of your pre-lab, I'll ask you guys to tell me what are these 3 variables for the other 2 experiments. So the name of the game is to generate our results so that we can look at them and see what happens as you go down a group. And visually, we're setting up our well plate like I'm reading down the column. So what happens is when I look at my wells, I will know what happens to a group is I visually look at my well plate, right, for what we're going to do. All right, so I'm going to take you back to the lab and quick walk you through what we do. Okay. I sent you guys over here. Tip it down. A couple things you'll see going on right over here. These are my three controlled variables. It's my carbonate for experiment 1. It's my sulfate for experiment 2. And it's my chromate for experiment 3. And if you take a look at those liquids, none of those liquids have any solid in them. They would be what we describe as clear liquids, the first 2 being colorless, the third one being yellow. If we look over here, I've got my group 2 nitrates. So here's my beryllium nitrate. Here's my magnesium nitrate. My calcium nitrate. And so on and so forth. All right, so you guys get the idea. All right, then if I bring you over here, tip you down, what you're going to see is that I have set up some wells. Right? And going down the column here, I've got beryllium, magnesium, calcium, strontium, barium. There's my group 2 metals. All right, up here, I have each experiment we're going to do. My carbonate, my sulfate, my chromate. All right, so I'm going to try to spin you guys so that you see it the way you would if you were standing in the lab. Okay. All right, and what I'm doing is I'm taking 10 drops of each of these guys. All right, and I'm putting them across the 3 to set up all 3 experiments. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of the beryllium. 2, 3, 4, 5, 6, 7, 8, 9, 10 of the beryllium. 10 of the beryllium. I do the same with the magnesium. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Magnesium in this next one. Magnesium in this next one. Then I do the calcium. And no solids are forming because I haven't mixed anything yet. All that's in that first well is calcium. All that's in this second well going across is still calcium. Third one's calcium, right? I'm just prepping those for each reaction. And we do the same with the strontium. 10 of the strontium. 10 of the strontium. And then lastly, 10 of the barium. A little bit more. 10 of the barium. 10 of the barium. 10 of the barium. All right. So totally worth noting right now that none of these have any solid in them. Any precipitate is the fancy name for a solid that comes from 2 liquids because we haven't mixed anything yet. So now what I'm going to do is I'm going to introduce my carbonate. All right, so I'm going down this first group and I'll put my 10 drops of carbonate. 10 drops of carbonate. 10 drops of carbonate. 10 drops of carbonate. 10 drops of the carbonate. Then I'd go through and I'd do my sulfate, right? 10, 10, 10, 10, 10. Then I do my chromate. 10, 10, 10, 10, and 10. And then what we'll do is we'll gently shake this for 3 minutes, and then we let it sit for 5 to 10. Now, I'm not going to make you watch that. I started this experiment a bit earlier in the day. So I'm going to bring in the one that I had set up earlier. So here is what you would have seen 10 minutes later. All right, so what I want you guys to do is make observations on your well plate. right, in terms of the amount of solid that you're seeing as you work your way down. And remember, the top row is empty. There's no liquids in that because we didn't need it. The second row, these are my berylliums. Right? So in your data table, you're going to give it a number ranking, 1 to 10. 10 is I formed a ton of solid when I did this. All right. 1 is I formed no solid. 5 is there's solid in there. 6 and so forth, right? So you're mostly setting up a comparative as we go through. Right? So if I tip this up for you, and give me a second, try to get you guys in good look. Tip this up. You guys can see each of these reactions as you go through. All right, so this would be a good time. You could just pause the video. I'm not going to hold it here forever. Right, and then you can make your observations for each experiment. So the first vertical column, this is experiment 1 with your carbonate. Second column right here, sorry, right there, the middle one. This is experiment 2. And then this column here, this is experiment 3 with the chromate. All right, so give it a pause, make the observation. And then once you fill in those tables, all right, what you're going to have to do is add 1 column to the top, because that was just an old lab that I used. All right, and in class, I would always have you add the beryllium column at the top because it just had the 4 metals in it. All right, so hopefully you made your observations on those. All right, and now what you'll be ready to do is make some conclusions about how things are going to happen. And you, at the end of the day, should hopefully be able to tell me a pattern about what's happening. Is the reactivity increasing as we go across? Is it decreasing as we go? Right? Is it going up and down, which means there would be no pattern? And all of the post-lab questions revolve around that. Right? But what we'll do is we'll regroup for that stuff, all right? And I'll be able to field questions on anything that you guys weren't sure about. All right, so I will see you guys very shortly.